Hello everyone, and in this video I'm going to show you how to create this moving platform here. This moving platform has a lot of functionality that is very easy to toggle, such as looping the track and changing the stall point times in between each point. So I'll show the midpoint stall time. So once it gets to this point, it'll stall for a second here, and then it'll go up and it'll stall for the full end point time, which is 2 seconds. It can also loop track, so we can loop track like that. And so as it goes through here, we can see once it gets to the top, it'll just go straight down. Along with this, we can also ride it using our first person controller that I've created in another video. However, this should work for any sort of controller, whether it be third person, first person, or so on. This should work for any controller. And we can see that I can ride it just fine. And I can jump off it and everything works just fine. So yeah, let's get right into it. So let's go ahead and get started. So I've created a new scene, and there's not really much in the scene. There is a player object that is using a first-person controller that I created. This is actually the same first-person controller from another one of my videos that shows how to create a FPS controller. It's been marked player, and other than that, it's just a camera and then this model that has nothing on it, and then this FPS controller here. If you want to see how this is made, watch the other video I created on how to make a FPS controller. And then under environment, it's just a bunch of cubes just to show how we're moving and that everything is working great. So to start this, we're going to create an empty object, and we're going to resize transform, and we're going to call it the platform. Now under this, we're going to create a platform controller, and we'll just create an add. Go ahead and open this up. So we're going to want to start with a serialized field that has a transform as the object that we're going to want to store, and it's going to be the waypoint's parents. Well, the parent. So what this is going to be is it's going to be a header object that is going to store all the waypoints that our platform is going to travel along. Next, we need to have a float that is going to be the travel time between the points, and we're going to say 5 for right now. We're going to want to have a end point wait or stall time. We'll say 3, and we'll have a float that is going to be a midpoint stall time. Now these are completely up to you. You can just edit these in the editor and change how your platform moves and stuff. But for now, I'm just going to store these values in there just to give it a value. We're going to need a float t, and this is going to basically tell our object how it's supposed to move between each point, and it's going to store where we're at currently. And then we're going to need a vector3 starting position, starting point, and then vector3 ending point or target point. Next, we're going to need to create a start method, and we're going to also have to check something else. So we want to have a bool of a loop track, and now what this is going to be is going to allow you to edit whether the track will loop around once it gets to the end, or whether it's going to move backwards and basically backtrack the movement track. So we'll say this is false by default, and we're also going to have a bool moving forward. So this is going to also be whether we are moving forward along the track or if we're going backwards along the track. And this will be true by default because it always starts by going forward. Next, we're going to want to get all the waypoints and store them. So in order to store them, we're going to have a list of vector3s, and we're going to say waypoints. And we're going to say waypoints is equal to a new list vector3, and then we're going to say for int I equal to 0, I less than the waypoint's parent dot child count I++, and then we're going to say waypoints.add waypoints parent dot get child I, and then we're going to say dot position. Now the reason we're doing it as storing the actual vectors is since we intend on creating a prefab of this object, whenever it actually moves along the track, so will the waypoints, and we don't really want that to happen whenever our actual platform is moving around. So instead, we're going to store the positions before it starts moving, and so then after that, it really doesn't matter whether the waypoints move or not, which they will, because you know we already stored the positions. So after that, we're going to want to do a very basic check. We're going to say if waypoints.count is less than 1. So if you have either one spot or no spots, then we're going to say debug.error or log error. And we're going to say you need more than one waypoint to travel along. And this is just an error just to make sure, like, if you have one point or no points, then really you just have an object sitting in space and you don't really need this script to work. Because, I mean, you can just place an object in Unity and it won't move by default. And then we're just going to turn this off. This is just to make sure we don't have any errors. So in case you do have a platform in the game that doesn't have any waypoints, we don't want it to break anything. However, it will warn you that there is nothing so that you can see in the console. Now then, we want to store an integer value that's going to be the current point index. And we're going to set that to equal to 0. And just to make sure, we're going to set it equal to 0 again down here. And then we're going to say that starting point is equal to get current waypoint. And we could actually just say get waypoint. And then we're going to say get next waypoint, and we will fill out these methods in just a minute. So let's go ahead and just create a method that gets the current waypoint. So we'll just get waypoint, and this method is pretty simple. And then this other one is going to be a bit more on the complicated side. It's going to basically check our list of waypoints and see where we're at, as well as check other conditions to see whether we should loop the track or what other information we need to handle. So get next waypoint. Now what you could also do is you could have this current point index be set equal to this. So you could say current point index is equal to that, and then pass in your value here, and then pass in your value here, and then return an int. You could do it like that. I'm not going to do it like that because it's all contained within this class, so it can just be edited from here. So for the get current waypoint, all we have to do for this one is return the waypoint's current point index, and that's it. That's all you have to do. You're just returning the current vector3 point that you need. For this next one, you're going to have to do a bit more stuff, and we'll come back to that because we need one more thing, is target point is equal to get waypoint. So now we're setting the initial point as the current waypoint, as the 0 point, and then setting the target point equal to the other waypoint. So after we do all that, we'll just do transform.position is equal to starting point. And just the reason we're doing this is just in case your track is not lined up already with your waypoint, and I'll kind of show what I mean by that in a little bit. Then this just makes sure it's in the proper position. So in here, we're going to have to do a couple checks and also get some logic down in order to prevent errors and other things. So if we are not looping the track, here, we need to check if we're moving up. So if we're moving up in the track, so moving forward actually is what I named it. So if we're moving forward in the track, we need to increment the current waypoint, so current point index increased. And then we need to check if the current point index is greater than or equal to our waypoints dot count. So if we're at the last waypoint and we are going to our next point, then we need to actually just set it to the waypoints dot count -2. So this will basically say if we're past all of our waypoints, then set it to the one before the last one. So waypoints dot count -1. What this will do is get the very last waypoint. So this is the very last waypoint in our list of waypoints. -2 is the one just before that. And this also works if your waypoints, if there's only 2 of them, this will also work, because this will evaluate to 2, and then this will subtract off 2, which means it will be 0, which is our very first waypoint. And then if this is true, we need to say moving forward is equal to false. So now we're moving backwards. On the other hand, if we're moving backwards, we need to do a -, so we're going backwards now. And if the current point index is less than 0, so if we're at the 0th one and we are trying to go back further, then we need to say our current point index is equal to 1, and then say our moving forward is equal to true. So basically just the exact opposite of what the moving forward is doing. Now then, loop track is a little bit different. It is always going to increase the index, so it's always going to be this. However, if the current point index is greater than or equal to the waypoints dot count, then we're just going to say that the current point index is equal to 0. So looping through the list instead. So that's all we need for the get next waypoint, and that's all we need for the get waypoints. Now then, we can move on to the update method. So one other value we'll need for this is we'll need to do float stopping distance threshold is equal to 0.05. And so this is just because for Unity as well as other programs, floating point values are not always perfect. So you need to set some sort of value just to make sure that it doesn't have to be exactly precisely on the point. And so we're just setting it slightly above here, and I'll show what I mean by that in just a second. So if vector3.distance between our transform.position and our target point is less than or equal to the stopping distance threshold. So what I was meaning here is if the distance is less than or equal to our little threshold here, and as I said before, this will never be exactly 0, or sometimes it could be, but this will usually not be exactly 0. So this is just to make sure that we're at least close enough that it will work just fine. So, and this can probably be set to something smaller, like 0.01. However, I'm just going to do it as 5 because that usually works out the best. So if we are at the point, our target point, we need to start incrementing some sort of dwell timer. So let me create a dwell timer here. And so this will go through each one of these, and this will actually be incremented and then checked between these two things to see if either one of them passes. So in this point, we need to say dwell timer plus equal time.delta time. So just incrementing the dwell timer up. And then we need to say if is at endpoint. And this is a method we have not yet created. So let's go ahead and create that. Now what this is for is it's simply because I have 2 different endpoint timers here. You could actually not worry about this at all. You could just do one single point stall time, I guess you could say. However, if you want to have different kind of stalls between whether you're at the end or at the beginning, then whether you're at the end or in somewhere in between, if you wanted different times, then this system will allow you to do that. So if we're at the endpoint, here, we're going to say if dwell timer is greater than or equal to the endpoint stall time, then we're going to want to set something true. Now, the reason I'm saying set something true rather than just doing our function in here is because they are both going to do the exact same thing. So you might as well just put them together and do it this way. So we're going to say continue track is equal to false. So we're setting it to false by default. So at this point here, we're going to check the continue track. And if it's still false, we do nothing. But if it's true, that's when we're going to iterate to our next waypoint. However, in here, we're just going to say this is equal to true. And then if we are not at the endpoint, then instead of checking the endpoint stall time, we're just going to check the midpoint stall time. And if this is true, we're going to do continue track is equal to true. So this is set to false by default. If either one of these is true, it sets it to true. And then this is where we just do if continue track is true. So if either one of these passed, then we're going to want to do starting point is equal to target point. So since we've already gotten to our target point, since we already got there, then we're going to want to set our starting point at that point. Then we're going to want to get the next waypoint. And then we're just going to say target point is equal to get waypoint. So this sets it our starting point to where we're currently at. This is where we should be at currently. Then we're going to get the next waypoint index. And then we are going to set our target point to that next waypoint. And actually, now that I think about it, this is saying this does the index. It doesn't get the next waypoint. It gets the next waypoint index. Then this just gets whatever their current index is. And then in here, we'll just return. Because if we're at our point that we want to be, we don't want to do anything else. And we are just about to do something outside of this if statement. So if we're not at our target point, then right here we're going to want to do something else. So we're going to say time the t value. Speaking of which, I need to do t is equal to 0f, and then also reset the dwell timer. So this just resets our values here. That's all that's doing. But you need to do that in order for all this to work. So for our t value, so this is for our linear interpolation between the 2 points. We're going to want to say our time dot delta time. So whatever time was between the last frame and this one. And then we're going to want to say our travel time between points. And so now this will allow us to perfectly interpolate between one point and another point without any sort of slowdown or anything else. And then we just want to set our transform dot position equal to the vector3 dot lerp, so the linear interpolation, so this right here. So it's going to interpolate between 2 points, that's A and B, and then we're going to throw in our t value here. And so we're going to say our starting point, our ending point, our target point, and then we're going to throw in our t value. And so now this should make everything move just fine. So if we go ahead and run, however, we do need to actually create our values here, and it seems as if, oh, we have not yet filled out the ending point. So all this has to be is if the current point index is equal to 0, or current point index is equal to waypoints.count minus 1. So if we are at the very beginning, or if we're at the very end, the very last one, we're going to want to return true. Otherwise, return false. And so now that should work just fine. And so that should be all the code in terms of movement. Now this is not going to allow our player to actually move along anything. However, this will allow our actual platforms to move. So I have this platform object I created a second ago, and I'm going to create an empty object under, and I'm going to call it the waypoint. Actually, I'll just call it waypoints, so it's all the waypoints. And then let's just go ahead and prefab this really fast and go into the object. And so now under this, we need to connect the waypoints parent to here. So we pop that under there. And then we'll go ahead and create a 3D object cube, and this is just our model. It also allows us to stand, so you have to have this object under here in order for it to work. So I'm just going to make it a little bit smaller, like that. And the reason I mean that, the reason I say this has to be on here is because it will technically work if it's not on here. However, your character will not be able to stand on the platform without, the actual platform. So you need a empty box collider, a non-trigger box collider, and just some sort of object. Cube object is what I'm using for your player to stand on. The top level will need something else in a little bit. However, right now it just needs this waypoints. And then we have an empty waypoints object. So now then, back out here, this has updated and I can start to create some waypoints. So I'll create waypoint 0, and then I'll just duplicate this a couple times, and I will also pull the platform up so that you can see it. And there's one other thing I would like to do so that it makes it really easy to see your track, because something important to see whenever you're designing your level is you want to see where your track is actually going. So onDraw Gizmos is going to help us with actually seeing our track, and we're going to have to do a simple check here. If the waypoints parent is equal to null, we're just going to return out of it. Otherwise, so if our track is not null, if we have some waypoints to go through, then we're going to say for int I equals 0, I less than a waypoints parent dot child count I plus plus. And then for here, we're going to want to do gizmos dot draw sphere at the waypoints parent dot get child I dot position, and then we're going to set some sort of radius, so I'll just do 0.5. Let's also make sure we have a color we want, so we'll say gizmos dot color is equal to, we'll say color dot white, seems fine. And so we'll have a sphere drawn here, and then we're going to do int next waypoint is equal to I plus 1, so the next waypoint. And if the next waypoint is greater than or equal to waypoints parent dot child count, then we're going to want to just break. However, if this is not true, so if we still have other waypoints to iterate through, then we can say gizmos dot draw line from the waypoints parent dot get child I dot position, and then we're going to draw it to, so we're going to draw the other line, the connecting point, as get child next waypoint dot position. And so now what this will allow us to do is we're going to add a sphere to every single point, every single waypoint that we create. We're going to see if there's a next waypoint, and if there is, we're going to draw a line between this current waypoint and the next waypoint. And if we get to the end of the waypoints, it won't draw any more lines. Instead, it will just draw a sphere. So go ahead and save that up, and we can open this back up, and you can kind of see a ball get created. Now then, if we just move out some of these points, you can kind of see the lines being created here. And you can see how it connects here, 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 and here. And so if I run the game now, and I turn this back on to scene view, you can see it actually traveling along the path I set. Now, you'll notice that the track comes over here. That's just because for onDraw Gizmos, it will draw it for the actual positions of the actual game objects. However, we store just the vector 3 positions, so that will affect nothing. onDraw Gizmos is really just for the editor view. You will never see this in game when you actually play. So if you actually play the game, you don't see anything. Nothing's visible. However, in the scene view, it helps you kind of create your little path here. So this seems to be working. It is going along the path, and it also goes backwards, so I'll try to show this track here. So it should come over here, and then it'll go down, and then to the like diagonal here. So just give it a second. And you can also see it's stopping at every midpoint, and it's also going to stop at every endpoint. And then from here, it'll go back and reverse the track. Now then, we can also play with some of these toggles. So some of these things we can edit here. So travel time between points is set to 5, so I would like some a little bit faster, so I'll do like 2. Endpoint stall time, we'll do 5 seconds. And then for the midpoint stall time, I don't really enjoy the stopping in between the points, so we can just set that equal to 0. And so now we can see that it moves just right past the first 2 points, and then it'll stop here for 5 seconds, and then it will go back. So just give it a second here, and then now it's just going back, and it will stop at the very beginning again. Along with that, if we turn on loop track, it will go to every single point, and then it will, rather than backtracking, it'll just go back up to here. Another thing we're going to notice is that it actually stops at that last point. Even though we're at looping track, it stops at the last point. Now, you may like this, you may not like this, and to fix that is actually really simple. So we'll go back into the code, go up here, and we'll look for the loop track, and we'll just add one more value, another bool under it. So we'll say stop at ending point on loop track. And I'll say false for mine by default, because I would like it if it's looping the track, it just ignores it and goes all the way through, and it doesn't stop at the actual thing. So we'll say if we're at the endpoint, we'll do a question here. We'll do if loop track and not stop at any point on loop track, and the current point index is equal to the waypoints dot count minus 1. So if you remember down at is at endpoint, we check if it's either 0, which is the very first position, or we check it if it's the very last position. So here we're just checking to see if it's the very last position. And if it is, then we're going to say continue track is equal to true. And it doesn't matter, this doesn't need to be in an else statement or anything, or else if statement. It can just be just like this, because if either one of these are true, it's going to do the exact same thing. So we don't have to do anything here. We can just go back into the editor, and we can see another thing pops up here. And if we run this again, go back into scene view, and then turn on loop track. Once it gets to the end here, it'll pause. It won't pause anymore. It'll just go right back to the initial point. However, if you want it to, pause at this endpoint, if that's what you like, you can actually turn that on. And then we can see once it gets here, it'll stop again for the exact same 5 seconds. And we can just kind of wait for a second here, and then it'll go back. And we can just turn this off just like before. And if it goes all the way back here, it will just immediately loop back. Just like that. And we can just turn off the loop track, and instead of looping all the way through, it'll just go back along this track again. So once it gets back here, it'll wait for the 5 seconds, and then it'll loop back on the track. One other thing you can do is you can just set this equal to 0, and then it won't stop at all. So just like that. And we can even set this to a little bit faster, and so now it just loops pretty quickly. So now that's all for actual movement. However, there is something we're going to notice. So if we just go ahead and put this track out here to where I can land on it, and we set the endpoint time to something I could actually stand on, and then we just do, that looks fine actually. So if we just go ahead and run it and try to find where we're at here. So once this comes back here, we're going to notice that something odd happens. So although the track is moving and everything looks great, whenever it actually starts moving with your player on it, you're just going to fall through, and it's not going to move you at all. So the way to fix this, we actually need to do one other thing. So if we go under the platform, we need to do a box collider, and you need to set the trigger to is true. And then we need to modify this trigger so that it sits above our actual platform model. So this is just our model, plus it allows us to stand on it. But this box collider is different. It allows us to actually be moved whenever the platform moves. So I'm going to set it to the same dimensions as my cube. So my cube, which is my platform, is a 5 by 0.2 by 5. And my box collider is a 5 by 0.2 by 5. And then I'm just going to move it up to 0.2, and we'll just say 0.21. And then if we look here, it's just barely above the track here, but it is completely covering that track. So now then, we need to go back under the platform controller, and we need to do two things. So we need to have a transform, and then we're going to say player transform parent. So we need to have one of these. And now this is only for restoring the parent to what it was before. And I'll get back to what I mean by that in just a moment. So under the draw gizmos, we need to have an on trigger enter. And then we need to just check something. So other.gameObject.tag equal to player. Then we need to say that the player transform parent is equal to other.transform.parent, and then we'll say other.transform.parent is equal to transform. So what this will do is we save whatever the last parent was. So whatever the other object's last parent was, we save it. Then we will set our player object's parent to this transform. So whatever movements this transform makes, our player will make it as well as adding on to whatever movement the player makes. So now we also need to have an on trigger exit, and if the gameObject.tag is equal to player, all we need to do here is player. We just need to set the player transform equal to what it originally was. So now then, this should all work perfectly. Now, something to note here. If our player, similar to my actual player in my game, if it has no parent object, so if it has no parent object at all, then this value will be null, which is fine. It doesn't need any sort of check to see whether it's null or not. It'll work just fine, because you can set, whenever you set an object's parent to null, it actually just puts it in the hierarchy, in the main hierarchy. So for example, this player object here, its current parent is null, but this FPS cam's current parent is player. So this will all work just fine. It doesn't need any sort of check or anything. Now then, if we just go ahead and run the game and look over here and just come back over here and wait for it to come back around. Just give it a second. We can now hop onto it, and now we are currently parented under the platform. You can see it in the hierarchy here, and you could also see us moving away from the platform we have over here. So now I'm able to ride on this just fine, and everything seems to be working just fine. So we're moving away, and I can jump back on over here. One other thing is that these tracks are completely able to be moved around and everything. So if I just move this up really high like that, and then before we start this, I would like a smaller wait time. So we'll do like 2. And so now let's go look for our track. So it'll go up there just like that, and everything works just fine. And now let's just have us on it and see how it works there. So we're moving just like before, and now we're moving up. So yeah, everything seems to be working. That should be all for this. So if you guys like this video, like and subscribe for more. And thank you all for watching.